Hi guys. Okay, so I'm going to start going over the chapter review assignments. There's two of them. I'm going to do question one and question two first. Okay, so it starts off in the review. It talks about the National Center for Health Statistics distribution of heights for 15-year-old males. Okay, it tells you it's symmetric, single peaked, bell shaped, and then for the distribution, it gives you a z-score of 0. Right, corresponds to a height of 170. And a z-score of 1 corresponds to a height of 177.5. So let's just review real quick on what that's talking about. So you have the standard normal distribution. Okay, the mean of a standard normal is 0. And if this is 1, that tells you that your standard deviation on the standard normal curve is 1. Okay, now that's for all data. If you have particular data that's not z-scores, it's talking about heights of males, it's telling you that a mean of 0 corresponds to a height of 170. That's telling you guys that the mean of the distribution of heights is 170. And it tells you a standard deviation of 1 corresponds to a height of 177.5 centimeters. Okay, so this is heights, and this is the standard normal, which is z-scores. And so what you're supposed to remember is your mean is your center of your peak, right, of your symmetrical distribution. So a mean of 0 would correspond to 170, tells you that the mean height is 170 centimeters. If they tell you that a z-score of 1 corresponds to a height of 177.5 centimeters, you know that the difference between 170 centimeters and 177.5 tells you one standard deviation is equal to 7.5 centimeters. Okay, so on question number 1, it says find its mean and standard deviation, show your method clearly. So that's how we would do that. Okay, so that would be A. And then question B says what height would correspond to a z-score of 2.5? Show your work. Okay, now after looking at your guys' quiz scores, clearly you're finding some online stats calculators that is great. You're getting answers, but you have no really idea of how you're getting them, and you're not using the process that I'm teaching. So make sure that you guys are showing your work on the test. So to switch between data point and a z-score, you know that z is equal to the observed value minus the mean divided by the standard deviation. Okay, so what they're telling us is they're saying, look, what corresponds to a z-score of 2.5? Well, we know now from part A that our mean is 170 centimeters and our standard deviation is 7.5 centimeters. And so if you simplify that equation, you get 2.5 equals, I don't know the height, minus a mean of 170, all divided by a standard deviation of 7.5. Okay. And again, in the quiz review, you could always go back and watch. I worked this out for you. A lot of you are just using some calculator you're finding online, and it's very easy to see that. Okay, so when you do this, what you want to do is you want to multiply both sides by 7.5. And so you do 7.5 times 2.5, 18.75. These guys cancel out, x minus 170, and then simple algebra says add 170 to both sides. And when you add 170, you get 188.75 centimeters. Okay, so you can switch between a data point of any data to a z-score by this formula, and you can also go backwards. Given a z-score, you can go backwards and find the data value, right, based on a mean and a standard deviation of your distribution. Okay, sorry about the bird in the background. Just have to get used to it. All right, number 2 talks about same data, right? Paul is 15 years old and 179 meters tall. Find the z-score corresponding to Paul's height. Okay, so if Paul is 179 centimeters, what is his z-score? Well, his z-score would be 179 minus the mean divided by the standard deviation. And again, in your calculator, don't make an algebra mistake. 179 minus 170, you need to hit enter first to get 9, and then divide it by 7.5 to get your answer of 1.2. And that is a z-score. right? And so at the beginning of the chapter, the question is, what does that mean? Your z-score tells you two things. It tells you how many standard deviations away from the mean you are and in what direction. So you would say Paul's height is 1.2 standard deviations above. How come above? Because it's positive, the mean. Okay, so Paul is definitely taller than the average person, which we know. And so how much is 9 inches taller? Well, it's 1.2 standard deviations above the mean. Okay, all right, part B, and then I'm going to stop this lesson. We'll just do a couple problems at a time. Paul's height puts him in the 85th percentile among 15-year-old males. Explain what this means to someone who knows no statistics. So what does it mean that Paul, this is part A. So part B, you have the 85th percentile. Okay, and what that means is that Paul is taller than 85% of all, go back to the context of your problem, 15-year-old males. Okay, taller, 85% of all 15-year-old males. Okay, so that's question 1 and 2. I'm just going to chunk these up so it's easy to review, and then you can watch them at your own convenience.